says here in the scale diagram, two forces, force 1, force 2, act on a 4-kilogram block at point P. Force 1 has a magnitude of 12 newtons and is directed toward the right. Using a ruler and the scale diagram, determine the magnitude of force 2 in newtons. So all we have to do is find the scale that they use. How many centimeters represent? How many newtons are represented by a certain amount of centimeters. So let me see. So that's 12 newtons are represented by 4.5 centimeters. So 12 newtons equals 4.5 centimeters. Now we want to figure out how much does 1 centimeter represent. How many newtons does 1 centimeter represent? So we divide by 4.5. 4.5 cancels. 12 divided by 4.5. 12 divided by 4.5 equals 2.6, 2.7. So 1 centimeter equals 2.7 newtons. So, alright. So, let me go back to this. Measure the other one now. Okay, that's about 3.25. 3.25. So 3.25 centimeters. 3.25. So if 1 centimeter represents 2.7, how much does 3.25 centimeters represent? So all we have to do is multiply 2.7 by 2.5 by 3.25. So 2.7 times 3.25, 8.775. So that is the magnitude of this vector right here. That's how many newtons it represents. So 8.775, 8.8 newtons. So that's the answer. 452. That's about the answer. Determine the magnitude of the net force acting on the block. So if we have a force of 8.8 newtons going that way and 12 newtons going that way, all we have to do is subtract the two forces, and then we'll get the force that the block is actually affecting the block. So we subtract these two forces, we will get the force that is affecting the block, because some of this force here cancels out with this force here, so the remainder is what's actually affecting the actual block. So we have a force of 8.8, we have another one of 12.0 going in the opposite direction, so they would cancel each other out. So you subtract them to get the answer. So this is 3.2 newtons. So that's the answer for 53. 3.2. Calculate the magnitude of the acceleration of the block. So that would be, let's see, acceleration was the formula. F equals ma. Yeah, F equals ma. Alright, so now we have to use gear. Given the mass was 4 kilograms. 4.0 kg. F 3.2 newtons. We just discovered that. And now we're trying to figure out acceleration. So equation, F equals ma. 4.0 kilograms equals m 3.2 newtons. So now we solve. 4. So we want m by its own, so we bring this over by dividing 4.0 kg over 3.2 newtons equals m. Let's find out what that is equal to. 4 divided by 3.2. Okay, 4 divided by 3.2. 1.25. So that's the answer that I got for this. 1.25 kilograms. No. F equals MA. Okay. That was the acceleration. Let me just fix this. I filled in the value for acceleration, for mass. No, what did I do? F equals MA. Okay, this is incorrect. Don't mind this. Let's do this again. The equation is F equals MA. The force is 3.2 newtons. Force. This is only incorrect because I filled in the incorrect values. So force is 3.2 newtons. 3.2 newtons. Now I'm filling in the equation. 3.2 newtons equals, the mass was 4.0 kg meters. Alright, because F equals M, which is 4 A. See, I'm gonna move. F equals MA. So acceleration. Force equals mass times acceleration. So we want acceleration on its own. 3.2 divided by 4. 3.2 divided by 4 equals 0.8. That's the acceleration. 0.8 meter per second squared equals 8. So let me write this all over. The answer for 52 is 1 centimeter equals 2.7 newtons. 53 was 3.2 newtons. And 54, 0.8 meter per second squared. Okay, let's see. 52. 9. No credit for 9 newtons. What? No credit for 3 newtons. Seconds. Allow 1 credit for 9 newtons. What was the question? Shit. Whoa. Ah, shit. So, this is not the answer that I got for 52. No, 50, yeah, 52. This is the scale. This is not the answer. The answer that I ended up with was 8.8. 8.8 newtons. So that will be a credit. Because 9 minus 0.6 is 8.4, and 8.8 is between 8.4 and 9, so it's a valid answer. 53, 3 newtons. 3.2, is that within 10% error? 3 times 1.1. Yes, it is. That's a valid answer. 54. What's the answer? 0.75. Let's see if that's within 10%. I believe it is. 0.75 times 1.1 And yep, it's within the 10% error. So these are all the answers for 52, 53, and 54 from the January 2005 physics regions.